When is a rational function 1 to 1, and what is its inverse? Well, if its numerator and denominator are both linear expressions, and neither is a multiple of the other, a rational function will be 1 to 1. By multiple, I mean they differ by a real number factor. So if I give you the function f of x is 2x minus 1 over 3x plus 5, my claim is that this is 1 to 1. What is f inverse? Well, recall in general how we find the inverse of a 1 to 1 function. We write y instead of f of x, then we exchange the symbols x and y, and then we solve for y. Solve for y. Well, let's write x over 1. Think of this as a proportion, and cross multiply. I'll get x times 3y plus 5 equals 2y plus 1. Distributing 3xy plus 5x equals 2y plus 1. Now I'm going to take a moment and remember what I'm doing. I'm trying to solve for y. So I need to get all of the y terms on one side, all of the terms without y on the other. I think I'll subtract 2y on both sides and subtract 5x on both sides. I'll get 3xy minus 2y. I want to get y by itself. If this was just a number, at this point I'd be combining like terms. But combining like terms is just the distributive property. That's just the same as factoring out the common factor of y. And now to get y by itself, I can divide both sides by 3x minus 2. Now I have y by itself. This is my f inverse. This lets me do one extra thing as well. I can find the range of f by finding the domain of f inverse. Right. Of course, the domain of f, those are all the points where 3x plus 5 is not 0. A little computation tells us that those are all of the points where x is not negative 5/3. But that's going to also be the range of f inverse. The domain of f inverse, then, those are all of the points where 3x minus 2 is not 0. Those are the points where x is not 2/3. And that will be the range of f. All right, I'm going to give you one of these to try. Let g of x be 4x minus 1 over x plus 2. And first find g inverse of x, then find the domain and range of g. Pause the video and try this now. All right, so we're going to write y is 4x minus 1 over x minus 2. And then we're going to exchange x and y to write x is 4y minus 1 over y minus 2. Then we're going to think of x as x over 1 and cross multiply. We'll get x times y minus 2 is 4y minus 1 times 1, which we can ignore. Distributing xy minus 2x equals 4y minus 1. We want to solve for y, which will mean subtracting 4y on both sides and adding 2x on both sides. We'll get xy minus 4y equals 2x minus 1. Now on this side we factor out the common y, and then we divide both sides by x minus 4. This gives us our inverse function. G inverse of x is 2x minus 1 over x minus 4. Recalling that our original g of x was 4x minus 1 over x plus 2, we can now write down the domain and range. The domain of g is all of the x's that don't make this denominator 0. When will this denominator be 0? When x is 2. The range of g is the same as the domain of g inverse, which is the set of all of the values that don't make this denominator 0. When will this denominator be 0? When x is 4.